So modeling. No, when I was speaking about modeling, any type of model can be made in any type of software. But which kind of analysis we want actually? See, the left side picture is showing a single story building with a plinth being connected in the gray. And there is a roof only. But we made this building to be modeled in plate element so that there will not be any manual sheets or calculation to produce to client, since those sheets to be verified by client. We don't want to do that, because if you want something more to be reviewed by clients, you will get more questions and you have to explain it more, even though if you are your Excel file or manual calculation is well good within codal reference, client will keep on asking questions because it was not properly recognized before. So we have to do this math or this procedure for some times with the client, but we in this case we avoided that criteria by modeling all the slab as a plate element as well as the foundation as plate element, so that we can avoid those interaction with the client, and these softwares are recognized well, so they do believe in their results, of course, with the proper documentation of all we consider. From the basic modeling, from the bottom to top, whatever building or structure is planned, we have to split it and model it properly to understand, to make the software to understand what we are supposed to do in the software. For example, for a simple story, we need a column, a beam, either the foundation a node or a foundation model itself, and there should be a beam which is to be supported by columns, and the beam to be used as a support to the slabs. This kind of procedure we have to follow it very thoroughly, because if we miss the load transferring point somewhere, the load will not be properly transferred to the column or beam. If you model that slab somewhere some 1 meter above the beam location, you will not able to transfer the slab loads into the beam, but in field, which is actually going to happen. So whatever we're going to construct in the field, it should be properly modeled in the software, so that you will get a realistic output and a proper results. So first modeling you should do from foundation to top, but while doing that, there will not be there will be many problems you will face, which is I have shown on a regular building in the left side of the slide, which is a simple building, a single story with a simple isolated footing, which is easier for everyone to model. But if you looking for the second picture in the same slide, which is a G+15 story building, and which consists of 3 blocks. In the all 3 blocks are connected at the ground as well as at the roof, only at the roof, not in all the floors. And these column locations are not properly as the left side building, and we do have more number of columns. So the first basic step is to position the column point in the software. How we can do that? In the stat pro, we have to define the node. We can type all the column location as a nodal point, XY coordinate. The Excel can be directly copied to stat pro, or we can directly copy to the editor file in stat pro. Whereas in the SAP and the E tabs, we have to define the grid first. It will be easier then, because the grid position, whenever we want, we can uh, use it as a reference point in the SAP or E tabs, which will make you very quicker in modeling. If you provide any number of columns, if your grid positions are marked very clearly in the first, you will be able to position the column very easily without any issue. So for stat pro and the E tabs or SAP, the positioning the column is the common point, but how we gonna do in the software differs. That is where we have to learn the individual software, how we supposed to do the activity which we want to do. So if you want to learn a software, this is the basic thing. You all know what we want. We want to locate the column position, but the basic thing, how we gonna do in software. For each software will have a different procedure or methodology to be followed. That you have to find it. Then the first step of modeling will be easier. So know how to do in a particular software, but what to do is the same for both software. How to do is the main point, which will differ from software to software. So it's simple. From the I was just explaining about the column position. The same principle applies for creating a beam, providing a slab, and how we supposed to connect everything. This is our basic thing which we need to be focused during modeling, because the model should be perfect enough to run the analysis. Otherwise, you can create hundreds of columns. If you don't create it properly, the analysis, the load transfer will not be proper, and you will not able to achieve what you intended to do. Because each software has different criteria to be followed. If you want to create a node in StatPro is different. If you want to create a node in SAP or ETAPS is different. But the main thing is you have to create a node, which is the column position, or you have to create a member, which may be a column or beam or a slab element. So this is the thing you have to concentrate each way. If you want to start from the scratch, take a simple building for only 4 columns with single story. Start how you are proceeding with that model in each software. Try it in StatPro, try it in ETAPS, and try it in SAP. For that, you will find which software is easier. And day by day, increase the number of columns, number of positions, increase the grids, increase the floor. Then you came to know which software will be used effectively for which structure. For me, both software can be utilized for any kind of structure, but for user, it will differ in the initial stage. After that, it will be used for any kind of structure, can be modeled in any kind of software. So it is better to start with a single software from small structure to a complex structure. Then the same thing, if you start with another software, it will be very easier for you to do the same procedure. If you learn StatPro or if you learn eTabs, you can simply copy the things for the other softwares, but you have to work it out so that you can achieve the things. So whatever software you use, the modeling is very important so that the load points to be connected properly. The assumption what we made from the input to be perfectly transferred to the software. Otherwise, the software will do, software will analyze, but you will not get the proper result. Since the software is strong, no, we made something wrong in our input. We made a software to understand something else because we want a Taj Mahal, but we have given the software some other masjid or some other structure, say Tanjore temple. It will not give a Taj Mahal. If you want Taj Mahal, you have to give a proper input for Taj Mahal, the software. So this is how it works. So the modeling is very much important in the in any software, but you have to learn how to model a structure and always have a reference. Why, if even for a single node or a element, why you are doing in such a way? Because in engineering, everything should have a reference. Because you are not the first person to start structural engineering in the world. There are a lot of great scientists already done the job. We can improve it, but we cannot start from the scratch. I mean the research, but learning we have to start from scratch if we don't know anything in a particular software. That is a different story. So if you want to make a node or any member or any action in the software in the modeling, you should make a proper reference how it is made earlier. You can verify in the organization. There will be any organization to have a set of backup files to be used for GET. And if you are not yet employed, you can refer any software reference from each software support pages. They do have a lot of questionnaire sections, and even Skill-Lync have a broader people to do clarify your doubts and how it will make it easier for you. So we can discuss about modeling more, but it is the basic concept. Either it is a node, either it is a small structure, either it is some 15 floors, either it is concrete or steel. The procedure remains same. You have to do modeling, but for what kind of structure you are doing, you should have a proper reference and why you are doing that. Or if you know something very analytical in your paper, that can be easily transferred to the model. So basic thing is we need to know what we need to do. And yes, properties of member. Okay, properties we can define it as into two vast section. One is a material property, another one is a sectional property. The material will be defined at the first. Either you're going to do a concrete structure or precast member or steel structure, or for whatever material you're going to use will be defined at the first in the project course. If you're going to define a material type for a particular project, you have to do some analysis which will be uh, which will cost how much, so that then the client will decide which he want with the time impact and the returns of his particular intent project. So material property, usually the client will define what kind of structure they want, or the architect will define based on the purpose of use. For say, if you want to build a foundation, you require concrete. You want to support a crane, you need a steel girder. So there is a difference. Which kind of material can be used for intent of purpose? So this property is a very important thing in the structural analysis, whether it is a concrete or steel, what kind of material we're going to use. Concrete means what grade of concrete you're going to use, what are the properties of the material, like in smallness, Poisson ratio, and everything. For these softwares will have a default properties for each kind of material, whether it is concrete or it is steel. We can select which kind of grade we're going to use. There will be a standard material property will be there. If you want to change, you can change it as per your project requirement, and or you can use it the default values if it is same as your project reference and code reference. And the first thing is the property of material will vary with not only with the projects but also the project location, because the concrete property in US is different. They will analyze it different. Their code is uh, designed in such a way with their analysis and the properties and name call it, and the unit they use it is different from other codes and other countries. So where usually if we are going to build a structure in India, we have to follow Indian codes. It is the sole purpose, then only your structure will be approved from the government. And if you're going to design a structure in Saudi, the client will call for American code. Or if you are doing a project in a so African region, the client may ask you for a European code. It depends. If some country don't have the individual codes, they will refer some other international codes. But each code will have each set of values with respect to their grade reference. So we should be very clear what material we're going to use. Those materials should be reflected in the material property of the model. Okay, we can keep on change it, but for the particular thing, it will be same. So this value, it should be very particular with respect to the code we are using it. Okay. The sectional property is, is a second topic which will allow us to get the section shape and size with respect to the sectional property value, because earlier I was saying about a bamboo stick which will carrying a 1 ton load. If you put 1 ton load over a steel beam, for this the property whatever beam I am just given as a sample will withstand, because these sectional properties are much more than what 1 ton weight of can withstand. Okay? So, but it is too much for 1 ton of weight of equipment. What is the optimum size you need to propose? You should have a rough calculation to assign a member with a proper cross-sectional value, because you cannot provide a 1 meter depth of beam for a simple tank support, and you cannot provide yes 100 thick 100 depth beam to support a gantry girder. So it depends upon the weight and the forces is expecting to be carried. So we need to have a preliminary sizes, but we can change it and rerun it anyhow. But this is the first section where we need to properly identifying the economical section. Economical in the sense you cannot keep n different types of beams. Simply, it is giving a economical weight. I am talking about the steel section, for example. Okay, there are 1,000 members in that in a structure in the floor beams. There are 1,000 beams, and you are giving 100 types. In the 100 types, all some 50 types of beams have very little weight difference with others. Means you have to combine those beams into a single property, which will reduce the fabrication cost. Okay, that time, and it depends. If the fabrication is automated, we can do whatever sections we want, but it's also have impact in the erection time. So it's a economical in the sense should be economical, should be viable, should be feasible in construction. In all aspect, it should be economical. That is the perfect mm, definition of economical. Economical is not stops only with the finance with respect to the weight. It's also depends upon further activities. You have to consider everything, then you can define it as economical structure. Because you cannot simply throw 1,000 types of sections, which will give results of in a 0.3 digit value is meaningless, because 0.999 and 1 is same for me, but fractionally it is different. But you have to do a math, yeah, calculation based on this kind of execution experience. So you have to define the section very properly. For a concrete, there are only 4 columns in a structure. Out of 4, all column loads are only 10% different, and you are giving 4 different types of rebar arrangement is not useful to the construction site. They may, if they may made a mistake to provide a stronger column, a weaker thing, which will cost you more than what you saved in the other 3 columns reinforcement. So economic in the sense you have to be very particular. Whatever we are saying is really a saving. So the section selection in the section property is very much important. While analysis, if whatever section you choose, the result is based on that. Once you designed, if you want to change some section property, you have to rerun it, and you have to be sure whatever provided section is analyzed and designed in same manner. Because in a case, if you are providing a 600 depth beam, you analyzed and you are getting some forces which will requires on 1 meter depth beam, you cannot simply design and sell it. You have to reanalyze the structure with 1 meter depth beam, since the member stiffness will take effect in the analysis. More stiffer will get more forces. So we have to be very sure while selecting the sectional property. If you select the section in a better way, you will have a reduced number of routine analysis to find a proper section. So nothing more. You can select whatever section you want, and you can analyze. Then it will take a long process to find a proper section. So this is the basic thing you have to take in mind while choosing the section property. And loads. I suppose it should be a very vast topic, but I try to minimize for you, try to keep you up in this. The dead loads, imposed loads, wind loads, seismic loads, air pressure, water pressure, temperature loads, other loads, if any. The dead loads. The dead load is the self weight of the structure or other materials used as a permanent thing, like equipment or something. These dead loads can be defined in different way in each software. The first picture is showing the start for how we can define the self weight of the structure. We have to input a command called self weight in the directional vertical direction in the moderator's y. So self weight in the direction of y in -1, which means it will take one time for the vertical load towards down. The same way, E-taps are SAB. We have to define dead load with the self weight multiplier 1. It's a simply 1. So these are the difference. If you want to define a dead load, start pro requires self weight command. E-taps require the define load pattern. We have to define self weight multiplier. This is the basic of starting the loads. We will see one loads one by one. That dead load is simply the self weight of the structure. And imposed load. These loads can be called as live load. It's not exactly the term used, live load is correct, so they have changed into imposed load, which is intended for non-permanent members or people or things which will be engaged in any kind of structure. For example, if you are in the home, there will be a movement of people and there will be a mobile things and so on. those kind of loads are taken care in the imposed load. So for this, which is the main criteria to define which kind of load we have to take, the function of building or structure intent to use. Yes, we have to design a residential building. We have to consider those loads in the floors. For example, 2 kN per meter square. Or if you want to design the industrial structure, minimum 5 kN per meter square, differs by building, structure by structure, intent to use. The purpose is differs, load is differing by the purpose. The floor and the roof levels. The floors load is different because there will be more people movement and more equipment movement and so. And a roof lay load or imposed load is for maintenance. Some cases for party. Yeah, that is different criteria. So there are some standard loads is defined in each load, IS standard or ACE, whatever code you take, they will define which kind of load and what is the intensity of load to be used in a particular structure in particular floor. Either it is a floor or roof, whatever it is. And for maintenance, if you take an industrial building or a residential building with some other purpose, you will have a maintenance period for say genset to be maintained regularly and lift to be maintained regularly. And whatever machines in the industrial structure to be maintained based on their manufacturer standard. So there will be a maintenance in any kind of building, whether it is a residential or commercial, or there will be a some sort of maintenance. In that case, there will be a temporarily imposed load will be there. Those loads will be well defined in the industrial criteria because we do have a much higher load during maintenance in the floor, the free floors where we will not consider the regular loads for maintenance. So this is we have to consider it very properly based on the intent of use. And the application of load in the slab is similar way how we consider the slab dead load in other two softwares.